All right, Math 2, we got lesson 2.2.1, dilations. All right, so we have done transformations before. We've done translations, reflections, rotations. And all of those were rigid motions, meaning they produced congruent shapes. The shapes stayed the same size, they keep their angle measurements. They might have shifted like they're facing, like especially if you're rotating or you're reflecting, how they're faced changed, but the shapes had the same lengths and the same angle measurements every time we did it. They were rigid motions. They stayed the same size. Not all transformations are rigid motions. In fact, we've got one today that is not a rigid motion. It's called a dilation. A dilation transforms, is a transformation that enlarges, so blows something up, or it reduces, shrinks the size of a figure. It still maintains the general shape, but the sides don't end up being congruent when you do it. So instead of making congruent shapes like translations, like reflections, like rotations, so those make congruent shapes, dilations instead make similar shapes. Now, similar shapes, I don't think I have it written on here. Maybe we get to that later. Oh, yeah, we do get to it later. Just for right now, know that similar shapes have congruent angles, but the sides are proportional. All right, so let's get to 2-47. Using a point of dilation at the origin, so we're dilating from this point, dilate it so that it is twice as big. Okay, so let's just go to A real quick. To get from here to A, I'm going up 2 and over 3. I'm kind of like using your slope triangles from last year. Okay, I'm going up 2 and over 3 from this point of dilation. Now, if I wanted to double it, I would just basically double the slope. So instead of going up 2 and over 3, I'm going to double that distance and go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. There's where A prime would show up if I'm doubling the size, because I'm just doubling the distance from the point of the dilation to each individual point. Now, anytime that we do this, we are going to get what color should I'll do this light color. We are going to get a line going straight from the point of dilation to the original point to the prime point. So we've got this straight line, and anytime you dilate, it's going to stay on a straight line from the point of dilation. Okay, doing the same thing with all the other points. Let's go to B. B goes up 2 and backwards 1. So instead of going up 2 over backwards 1, I would go up 4, 1, 2, 3, 4, and backwards 1, 2. So I'm just doubling the size of the slope there, because slope is related very closely with the distance. So I'm increasing the distance by 2. And notice it's on a straight line there. And we'll do that with all the other points. So 2, 2, so I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, and this is where C prime would show up at. D prime, 1, 2, so I'm going to go 2, 4, and there's D prime. And we notice that anytime that I do this, all the points line up with the point of dilation. So I'm dilating from the origin, and all those points have lined up. All right, let's make our new shape and see if we notice anything. So connecting my sides. There we go. All right, so there's our new shape, and it is twice as big. So I've dilated it and made A prime, B prime, C prime, D prime. What is happening to the coordinates? Well, let's see. So this coordinate was at 3, 2, and now this coordinate is at 6, 4. This coordinate was at negative 1, 2, and now it's at negative 2, 4. It looks like we are doubling the x coordinate and the y coordinate. So we see here that xy is becoming 2x, 2y, because I'm doubling the size. And that only works when you're going from the origin, by the way. But anyways, so I'm just doubling the size of all that because I doubled the slope. What is the scale factor? Well, the scale factor is comparing the image to the pre-image. So the copy to the original. And in this case, the copy to the original is basically saying that the copy, I can measure out lengths and things like that. We would count out like these lengths, like from B to A, this is 1, 2, 3, 4, 5, 6, 7, 8. So the copy is 8 units long. And I see that the original here was 1, 2, 3, 4. So it looks like my scale factor is 2, and that's the same as these two numbers here. So basically, I'm doubling the size. So when I double the size, we call the scale factor 2 because we're doubling the shape. So when you have a scale factor that's bigger than 1, you get a bigger shape. How could we make the shape that's half the size? Make a reduction instead, because this was an enlargement. Well, if we did half the size, then our new coordinate notation would be 1/2 x, 1/2 y. And that would mean that the scale factor is 1/2 instead. So if I wanted to do that, and I do, I would just do half the distance. So this one goes up 2 and over 3, so I'd go up 1 and over 1.5. See how it's still on that line that we did before? This one goes down 2 over 1, so I go down 1 over 1/2. Still on that line. This one goes backwards 2, down 2, so I go backwards 1, down 1. I'm cutting it in half. And finally, this last one, it goes over 1, up 2, so I go over 1/2, up 1. I'm cutting it in half. And now I've got something that is half the size. So our scale factor would be 1/2 for that one, because I went half the size. What assumptions can we make about the sides and the angles of the original dilations? So we already kind of talked about this with this copy and original thing, is I'm noticing that when I looked at the sides for the enlargement compared to the original, that they were in a ratio of 2 to 1. 8 over 4 is a ratio of 2 to 1. So that's what we call proportional. They're in proportion. This bottom side is 6, and this part was 3. That's still 2 to 1. So we can see that the sides are proportional. However, the angles look like they're about the same. Like this angle here looks like a little over 90, still a little over 90. And when we did halfway, it was still over a little over 90. It looks like those angles stayed the same the whole time. This one looks a little under 90, a little under 90, a little under 90. These angles look like they're all the same. So while the sides are changing in proportion to each other, it looks like the angles are staying congruent. So the sides are proportional, but the angles, not by, but, are staying congruent. And this is why angle, angle, angle did not work when we were doing triangle congruence. Angle, angle, angle doesn't work because it makes similar shapes instead of congruent shapes. See how all the angles are congruent, but not necessarily the sides? So angle, angle, angle makes similar shapes instead of congruent ones. All right, back to this one. We're going to enlarge this one by 3 times its size, but now our point of dilation is here, not at the origin. So when it's not at the origin, you can't just do 3x comma 3y. It's not possible. Can't do that. There's other things that you could do with the coordinate notation for this. I'm not going to show you because it'd be confusing. I mean, what I could do is I could move it back to here, then enlarge it, and then move it back. And we're not going to do that. It takes 3 steps. Let's just go back to what we were doing before, and we're just going to triple the size of our slope. So from this point to this point, I'm going up 2 and over 2. So for my slope triangle going from D to F, I go up 2 over 2. If I triple that, I'd go up 6 over 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's F prime. And notice it is on the line going from D to F prime. So it's just spreading out in a straight line from there. So we got D to F is up 2 over 2. D to F prime is up 6 over 6. We tripled the distance. Now to G. G, we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going 10 units to G. Is that really 10 units? That is 10 units. So if we're going to triple that, we're going to go 30 units. So that's 10 units. And then this would be 20, and then this would be 30 right here. Because I went from 4 to 34 there. Oops, wrong color. So that would be G prime. It didn't go up or down, it was just going side to side. So I just tripled that distance. And again, notice, this is really helpful if you double check your work. Notice that they're all on the same line as we are increasing the shape there. Also notice here, between F prime and G prime, look at that. F to G, F prime to G prime. Notice anything about those two lines? Did you see they're parallel? They're definitely parallel. So this line is parallel to that line. All right, let's do H. So from D to H, I'm going up 1, 2, 3, and over 1, 2, 3, 4, 5, 6, 7, 8, 9. So up 3 over 9. If I triple that, it's up 9 over 27. Oh, wow. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7. Sweet. Now, what if I miscounted when I was going through it? The best way to check to see if I miscounted is to draw a line. Ah, I did not miscount. See, that line goes straight through all 3 points, and now I know for sure that I didn't accidentally count out my points wrong. Oh, lines, you're so helpful. All right, so here's our new shape. And we now know that that shape is triple the size of our previous shape. Notice that this line up here is parallel to that one. HG is parallel to H prime G prime. So all of these angles should be the same. H should be the same angle measurement as H prime. F should be the same angle measurement as F prime. G should be the same measurement as G prime. So the angles are the same, but the sides are not the same. They're called proportional. So like if this was 2, this one would be triple that size and it would be 6. It's not actually 2, but I'm just saying what if. What if this one were 3? This side would be triple that amount and it would be 9. If this side were 4, this side would be triple that amount, and it would be 12. So the sides are proportional. They're in a proportion to each other. They're all triple the size. We are almost done. Here we go. All right, similar shapes. Okay, so similar shapes, the corresponding angles are congruent, just like those dilations we were doing, but the sides are in a proportion. So we've got 4 different shapes. We want to find out which one doesn't look similar. This first one's a little bit hard to see. We'd be looking for the angles being the same. A and C look like that top angle's the same, look like that angle's the same. Ooh, not so much down here. You see what's happening here? This angle here is over 90 degrees just by a little bit. This one's over by 90 degrees, and this one's over by 90 degrees, but this one is less than 90 degrees there. That makes D my non-similar shape. So that angle is not congruent to the other shapes. That one's a little bit tricky. Your eyes can kind of fool you. But if you really look at these bottom angles there, I think that's the best place to see what's going on there. Because we've got over 90, over 90, over 90, and then this one is under 90. All right, those were all facing the same direction. A little bit easier to see when they're facing the other direction. Now we're going to see what happens if they're kind of facing different directions. Okay, they still can be similar to each other, facing different directions. Remember, when we do similarities, they don't have to face the same direction. They just have to have the same angles and the same and proportional sides. I'm thinking that A and D, if you rotate A a little bit, it looks like it's pretty much D. And if I spun around B, I think it's pretty much the same. But what I don't think is the same is, look, this is a really obtuse angle right there, but this one's not quite as obtuse as that one. And those angles should be the same measurement. It doesn't look like they are. And I can also see that, this side is a lot closer to, this angle is closer to this side because that angle's so big. But that angle doesn't look as big as all the other ones. So these ones, C, because of that angle, it looks like it's not matching those obtuse angles from the other triangles. So I would probably say that one's the one that's not congruent. All right, are these two triangles similar to each other? So if they're similar, they would have to have the same scale factor, meaning the sides would have to be the proportional sides. Usually to compare sides, I start with one of my triangles. So maybe I'll start with this one. And I'm going to list the sides in order. 9, 8, and 5. Okay, those are the sides of that first triangle. Over here, the sides in order are 18, 16, and 10, going from the biggest side to the smallest side. So I'm going to compare that to 18, 16, and 10. So I'm comparing the largest side to the largest, and when I do that, this reduces to 1/2. When I compare the medium size to the medium size over here, I get 8/16, which reduces to 1/2. When I do the smallest side to the smallest side right here, it also reduces to 1/2. Are these triangles similar? Yes. Why? Because they have the same scale factor. This one is half the size of this one, because all the corresponding sides, the smallest to smallest, biggest to biggest, medium to medium, they all reduce to the same fraction, which means that they're proportional to each other. They're in a proportion of 1 to 2. This means that this is half the size of this one. So yes, the sides are proportional. Does a transformation, describe a transformation that maps dog onto cat? Okay, this will be interesting. So we have to use our imagination. So I think that if I do this, I think that O needs to be up where T would be, because O is between the smallest and the medium, and T is between the smallest and the medium. So step one, do a different color. step one, I'm going to translate dog so that O's on T. All right, so if I translate dog so that O's on T, real quick down here, this is what it would look like. So here's cat. That's pretty good. Now, if I translated O on top of T, it would look like that, so that this is G, O is now on top of T, and D's over here. All right, so start with the translation. Remember, the next thing we try to do is a rotation. So I'm going to rotate. G should correspond to A. G is between the biggest and the smallest, and A is between the biggest and smallest. So the next thing that I would do is I would, let's use this color, down here, I would rotate this one, but G wouldn't make it all the way down to A because this one's smaller. So when I rotated it, G would probably show up somewhere right here, and now our shape would look something like, oh, that's really bad. There we go. So I would rotate it. I'd take this shape and rotate it, spin it, so that G shows up on this line. So I'm rotating it so that G shows up on this line. D's hanging out up there. So second step, rotate, dog, about T. So we're going to rotate based off of this. So that G is on top of this line TA. So I'm getting G on top of that line. All right, now what we need to do is reflect, because I want D over to here. I want D to show up over here. And then we would have the triangles on top of each other. Remember, they're not congruent, so they're not matching up perfectly. But if I reflect over here, D goes all the way over to here. So I'm going to reflect over line TA. I'm going to reflect dog over line TA. And then my last step is I would need to dilate this one so that it actually takes up the same space. Because here I got dog up here, but it's not the same size. So I would need to double the size of dog, and T would be the center of my dilation. So it would spread out from here. And if I double the size of dog, we knew it was half the size. So if I double dog there, if I double dog, it would be right on top of it. So our fourth step would be to dilate dog about T. So I dilate from T with a scale factor of 2 because I want to double it. All right, which of the following similarity statements are correct? Is dog similar to cat? Well, let's see. When I flip this all around, D showed up over here, O showed up there, and we said that G ended up over here. So D-O-G, is that C-A-T? Yes, that, wait, dog similar to cat. Oh, wait. So this is the sign, I forgot to tell you. This is the sign of the similarity. So let's see. D is between the biggest and the medium. C is between the biggest and the medium. O is between 5 and 8. That's the smallest in the medium. A is between the, oh no, this is not working. A is between the biggest and the medium. That one doesn't work. Okay, so O and A are not corresponding. And then G obviously is between the biggest and the smallest. T is not between the biggest and the smallest. It's between the smallest and the medium. So that is the wrong order. For the same reasons, we can probably get rid of this one because O and A did not correspond. We just said up here O and A don't correspond. But this one right here does work because we said that O should have gone with T and G should have gone with A. So O goes with T and G goes with A. You know, just comparing the medium to medium, you know, small to small, large to large. And then the last one, we've changed the order of DOG to DGO. So I switched the O and the G. Well, over here, I switched the A and the T. So this should still work. NGO should be similar to CAT because we're matching up, you know, the similar sides. All right, that's all I got for you. Math hard. See you later. Bye-bye.